So, hello everyone, I'm Jessica Solanki, and today we will be looking over techniques of differentiation. We will know all the different types of differentiation techniques that we have and how we're going to solve. Let's begin. The first rule says that derivative of a constant. When we talk about derivative of a constant, it means that our fx will be given in terms of a constant, which is either 1, 2, 3, -1, -2, anything. Right? And when we differentiate that particular function, we should get a 0, because the rule says that if fx is equals to k, where k is a constant, then f dash of x is equals to 0. Is this rule clear? It seems to be easy, right? We all know that when we differentiate a constant, we get 0. Good. Then we have a power rule, which is again a very common rule that we know. If fx is equals to x to the power r, where r is a power and it's a real number, then we will have f dash of x will be equals to, we will bring that power in front, so that power will get multiplied in front, then we do -1 to the power. Easy to remember? I don't think so you would be having problem in this rule as well. So let's just move on. These are some of the examples that we need to consider whereby computing the derivatives. So we have fx is equals to x cubed. Now here, which rule we will apply? We just looked at two rules till now. One is constant rule, the other one is power rule. So which rule will we apply? Power rule. So easy, right? So we're going to bring we do 3 minus 1, that will give us 3x squared. Similarly, now whenever we have a function in terms of a root, so it's written here y is equals to root of x. So whenever we have a function of this kind, we always have to change the form of that function in terms of x to the power half in order to solve for the derivatives. We cannot differentiate this particular function in form of a root. Easy? So first of all, you need to get rid of the root. So instead of root, you will write x to the power half, which is same as root of x. And then same power rule, bring the power in front, multiply the power in front, and then you do -1 to the power. Right? And then you can follow on. The same rules apply for C and D. Now let's look at a constant multiple rule. What does it say? If y is equals to k of x, where k is a constant, then dy over dx will be k f dash of x. Okay, so which means that if we have fx is equals to 2x, where 2 is your k, right? And x is your fx. So in that case, what you will do is just the normal thing. Whatever the power is, it will get multiplied in front with a constant and then do -1. Any problem with this rule? Constant multiple rule? Shall we move ahead? Okay, good. So now we have sum and difference rule. When we say sum and difference, is where we have addition and multiplication. Normally, our equations are in the form of, in a form whereby you end up getting a plus or a minus in between, right? So if that is the case, then we can differentiate each of them individually, right? And then we have to put them as it is. So for these, fx is equals to 2x cubed plus 5x squared minus x plus 10. So first of all, we consider the first most part of that function which is 2x cubed. So you have to apply the rule here, which is you're going to multiply the power in front with the constant, which is 2 times 3 is 6x. Now you're going to do minus 1 to the power, which would be 3 minus 1 is 2. So see, you have 6x squared over here. Then you do the same thing for 5x squared, which is 5 multiplied by 2, that is 10x. 2 minus 1 will be 1, so we have 10x. And minus, when you differentiate x, you should get 1. And then this 10, it's a constant. We just saw the constant rule. If you have a constant, if you differentiate, it will become 0. So this is your answer. Do you have any difficulty in solving this type of equation? Anyone confused with this kind of equation? Okay, seems to be easy, right? Now, the question says that we need to find the gradient of the curve y is equals to x cubed minus 3x plus 1 at the point negative 2 and negative 1. Now, can anyone tell me, when a function is given to you, what do you have to do to the function whereby you can get a gradient? Anyone? If, for example, this equation is given to you, what will you do to this equation in order to find the gradient of the curve? In terms of calculus, what will you do? Anyone? Do you all agree? Do you all agree with the answer written there? Derive. So, whenever we differentiate a function, that differential part gives you a gradient. When you substitute a value in that differential part, you should get a gradient. Does that make sense? Easy? Are you still confused with that explanation? Is it okay? Okay. You have to find a gradient of the curve. So how are you going to find it? First of all, you have to derive. You have to derive this particular equation, right? Which would give me 3x squared here minus 3. So for good? So you have to derive this. Now, when you have this differential, now if you are given points, negative 2 and negative 1. So this is your x and this is your y. Right? So this is your x and this is your y. Now what you have to do is you have to substitute the value of x in this equation. When you do that, whatever the value that you will get here, that will be your gradient. So this is how you get a gradient or a slope of the curve. Easy? Are you still confused? So whenever you are asked to find a gradient of the curve, this is what you are going to do. First of all, you differentiate the function. Then you will be given with the points x and y. You substitute value of x in that function if that function consists of only x here. Since this function only consists of x here. So you will substitute negative 2 and then you will try to get a value. And that value will be your gradient. Okay, now let's move on. Okay, at what point on the graph of the function fx is equals to x cubed minus minus 5x squared plus x plus 8 is the gradient of the tangent negative 2. Now, for the first example over here, you were given with the points and you have to find the gradient. Now what is given to you? you are given with the value of gradient. You are given the gradient. You have to find the points. Is it clear? The question is clear? Or anyone still confused? Is the question clear to you? Good. So now we know the question. Now how are we going to solve it? First of all, we know one thing. When we differentiate a function, we get a gradient. Right. So now the gradient is given to you, which means we know this. We know that f dash of x is equals to the gradient. Sorry for the way it's been written. Okay, so we know that f dash of x is equals to gradient. Now, how are we going to find it? That's another question, right? So, what are you going to do? You first have to bring this fx here. You are going to differentiate it. Now, differentiating this function will give you, this is x cubed, so you will have to bring the 3 in front, which will give you 3x and then minus 1, so 3x squared minus 10x plus 1. Now, since you know that f dash of x is equals to gradient, so you can say f dash of x is equals to negative 2 here. Right. Now, you have f dash of x as 3x squared minus 10x plus 1, so you'll put this here, which is equals to negative 2. Now, what are we going to find? We are going to find the points. So, I am required to find the x and y values. So, if I will simplify this, I will get x as 3, that is 1 point, and x as 1 over 3, that's another. Now, how will I find my y value? Will I be substituting this in f dash of x or in fx to get my y values? Because points are always in the form of x and y. So where will I substitute 3 in order to find the corresponding y value? Will I substitute in f dash of x or fx? Any idea, anyone? Where will I substitute my 3? Okay, good. So I will have to substitute my 3 in fx in order to find the corresponding y value. And substituting 3 in fx gives me 1 over 3. And substituting 1 over 3 in fx gives me 7. Integer 2 over 2. Okay, yeah. So that's your answer. Anyone having any problem with this before we move further? Do you want me to repeat or? You sure? Okay. So that means we can move forward. Now we have to consider product rule. Now can anyone tell me when do we use product rule? When do we use product rule? What does the word product says to us? When two functions are multiplied. When two different functions, very good. Yes, so when two different functions are multiplied, that's when we use product rule. So if a function has an equation in the form of a product, whereby y is equals to fx times gx. Now I give you one example whereby you have your fx, which is equals to 2 times, or maybe we can say, yeah, 2 multiplied by x squared. Will you be using product rule in this case? Why not? Because this 2 is a constant, right? 2 is not a function on its own. It's just a constant which is multiplied to a function. But if you have your fx, which is equals to x plus 1 into x squared. Now, will you be applying product rule here? Will you? Can you apply product rule here? Yes. Why? Because there are two different functions that have been multiplied. Even though we can open up the bracket and solve for it, that's fine. If not, then we can still apply the product rule. So now did you get where we use product rule? Now, knowing that is one thing. Now we have to apply. We have to apply the product rule. And how do we apply it? The formula says that dy over dx will be equals to fx multiplied by g dash of x. So we put fx as it is and we multiply by the differential of gx, which is g dash of x, plus now we differentiate fx, that is f dash of x, and we multiply that by the original gx. Any problem with that formula? Anything confusing there? It's just that you will differentiate one function and then you multiply that by the original of the another one. Easy, right? Okay, I don't know what's that one for, that thing for, but your question is this. Differentiate y is equals to root of x plus 1 into x squared minus 10x minus 1. So now in this case you have two different functions that are being multiplied. So which rule we are going to apply? Any idea, anyone? Since there are two functions being multiplied. Product rule, right? So we will be applying product rule, but product rule has fx and gx. So we can just say that the first one over here is fx. So we consider root of x plus 1 as fx, and we consider x squared minus 10x minus 1 as gx. So these are the two different functions. Now what are we going to do? We have to, I strongly recommend you that you differentiate each function separately, like it is been written here, right? So fx is equals to root of x plus 1. When you differentiate, f dash of x will be 1 over 2 root of x. Anyone having any problem with how we get 1 over 2 root of x here? Anyone? Okay. So, how do we get that 1 over 2 root of x? Let's do it. Your fx is equals to root of x plus 1. Now what have I said for the previous example? Whenever we have root, we have to change it into the form of, how are we going to change it? X to the power 1 over 2. This is x to the power 1 over 2, right? It's not x multiplied. Then we have plus 1. Now if I tell you to differentiate this, what will happen? Now f dash of x will be equals to, I will have to multiply the power in front. That's what the rule says. Okay, let me multiply. And now I am having x. Now what will I do with the power? I do minus 1. So it will be half minus 1, isn't it? So that would be half minus 1 on top. And then what will happen to the 1 here? It will become 0, isn't it? It will become 0 because it's a constant. So now my f dash of x will be equals to, my half will remain as it is because it's been multiplied. What will happen on top? It is half minus 1. What is half minus 1? Negative half, isn't it? So it will be negative, this is on top, negative 1 over 2. This is half multiplied by x to the power negative 1 over 2. Now, my f of x, f of dash x will be, now you must be wondering, how did we get 1 divided by 2 root of x? Remember, we have a rule, exponential rule, that whenever we have a power which is negative, if we bring it into the denominator, it becomes positive. Do you know that? So which means that it will be 1 over 2 x to the power half. But I said in the previous example that we can manipulate root of x will be equals to x to the power half. So again, if we have x to the power half, we can put it in the form of root of x. So is this clear? So now did you understand how we get 1 over 2 root of x? Anyone having any problem with this? Are you still confused? So for good? Good. So now we have our gx, that is, so f dash of x is done, right? Now gx is equals to x squared minus 10x minus 1. Right? Now if I have to differentiate that, I will get 2x minus 10. Now I know f dash of x, g dash of x, fx and gx. I know everything that needs to be there for the formula. So I'm ready to substitute into the formula. So now dy over dx is fx multiplied by g dash of x plus f dash of x multiplied by gx. So what is my fx? That's the original root of x plus 1. And my g dash of x will come from here, which is 2x minus 10, right? Then I will have to add that by f dash of x is, what is my f dash of x? 1 over 2 root of x multiplied by x squared minus 10x minus 1. So for good? You okay? You all clear on how to solve product rule? It's easy if you will do it separately the way it is. I highly recommend you that you separately differentiate fx and gx, and you just have to remember that very simple formula and then you substitute it. So easy as it looks. Now let's see what comes next. Quotient rule. So when do we apply quotient rule? We apply product rule when two functions are being multiplied. That's what we saw. Okay. Good. So let's look at quotient rule. When do we apply quotient rule? Anyone, any idea? Yeah, either we say division or a fraction, that's the same thing. Yeah. So whenever we have a function in a form of division, whereby one function is in the numerator, the other one is in the denominator. Now, say for example, we have fx is equals to 2 over x. Can you apply quotient rule here? That's the function given to you. Can you apply quotient rule? Why not? Because 2 is a constant. You can always bring that x on top, which will become x to the power negative 1, and then you can solve for it using the power rule. Now if I say fx is equals to x over x squared plus 1. Now will you be applying quotient rule over here? Will you be applying quotient rule over here? Yes, because x is one function, x squared plus 1 is another function, and they are divided. So you will be applying the quotient rule. So we now know when do we apply it. Let's see how we have to apply the formula there. Now dy over dx, that is equals to gx. So we're going to put the denominator, the function in the denominator as it is, and we have to differentiate the function in the numerator minus, we are going to put the function in the numerator as it is, multiplied by the differential of the function in the denominator, divided by the square of the denominator. Now, you might get confused because there's a minus, so it matters that you always differentiate fx first, then you put the differential of the gx. If not, then your answer will vary because there's a minus there. If it would be plus, it wouldn't have been the problem, like product rule. So this is just a tip to remember. We always take square of gx, right? So just remember that the denominator here will remain as it is for the first one, right? We always, fx comes in the numerator first, so we take the differential of fx first and we put gx as it is, and then we do minus or fx times g dash of x, and then we have to take the square. Anyone having any difficulty in understanding that equation there? Oh no, sorry, I mean to say the formula there. Good. Now let's look at one example then. We have to differentiate root of x over 2x plus 1. As I said for the product rule, same goes here. I highly recommend you that you differentiate them separately, and then you just have to substitute it into the formula that's been there. So we just saw if we have root of x, then if we differentiate that, it should give us 1 over 2 root of x. I assume that you don't have problem with this now because we just saw step by step how it's been solved. And then for gx, we have 2x plus 1. So g dash of x is 2. Now, once that is done, the only thing that you need to remember is the formula, which is gx times f dash of x minus fx times g dash of x divided by gx squared. So what is my gx? 2x plus 1, which will come here. My f dash of x is 1 divided by 2 root of x. Then we have a minus here. And fx is root of x. Then g dash of x, as it's been written here, 2. Then we divide entire thing by the square of 2x plus 1. Easy? Anyone having any problem? with applying quotient rule. And we all know now when we apply quotient rule. Is there any problem? Good. What about others? Yes, that's the final answer for solving this equation if we have to find the differential. If you want, you can further simplify this, but if you just apply the rule over here or the formula over here, that's fine. You will get your deserved marks. They won't deduct any mark from here. Is it okay? Now, everyone's favorite, the derivative of trig functions. So you need to know when we differentiate sin x, it gives us cos x. When we differentiate cos x, it gives us negative sin x. And so on. This you need to remember. And then we have this is something very important to go over. Secant x is equals to 1 over cos x. Cosecant x is 1 over sin x and cot x is 1 over tan x. I assume we all know about this, right? This is where it have higher order derivatives. So first derivative, this is how you present them. That's what given here. F dash of x we write in the form of dy over dx. Now, can anyone tell me why do we write dy over dx? When your equation is given in the form of y equals to something something. Why do we write dy over dx when we differentiate that particular function? Anyone? Can anyone give me the explanation for that? Very good. Yes, we are differentiating y in terms of x. That's the reason why we write dy over dx. Good. So now, if we have second derivative, then we have double dash here, and then we do d squared y over dx squared. This is something you need to go over. Chain rule. Do you like chain rule? Do you love chain rule? I must say, chain rule is really interesting. This rule concerns the differentiation of composite function. So, chain rule is whereby you have a function and there is a function inside it. Right? There can be one function inside it, there can be more than one function inside it. It depends. So for these, we have fx is equals to f into gx. So we have this f is the outer function, right? And this gx is the inner function. So we have two parts of the function here. So now, y equals to x squared minus 3 to the power 3. Now this whole thing to the power 3, this is my outer function and this is my inner function. Because remember, when we have a function, we do, and we have a power, we bring the power in front, then we do minus 1 to the power, isn't it? And then we have an inside function here. So always remember one thing. This is how chain rule works. If we have y equals f into gx, when you differentiate it, when you do dy over dx, it will be f dash you will put inner function as it is, then you do multiply by g dash of x. Is this part clear to everyone? We have f, then we have gx in underneath. That's the inner function. So first of all, I will differentiate the outside function, which is f. I will differentiate f dash. I'll do f dash, and then I'll put the inner function as it is, which is gx. Then what I do is I take that inner function and I differentiate it, and I have to multiply that with this. Is this clear? This is sort of a rule that you need to follow. Is this clear? So far good? Or anyone having difficulty in understanding this? What about the rest? Are you all here with me? Okay. So let's look at this example, right? How we need to solve it. So we have y equals to x squared minus 3, and then we have to the power 3. Now how are we going to solve it? Dy over dx will be equals to, now this is my outer function, right? The one with the cube. This is my outer function. So what I'll do is, I'll bring 3 in front and I'll do 3 minus 1 here. So it will be 3. And I will have to leave this inner function as it is, which is x squared minus 3. Right? And I will have outside, we'll have 2 because it will be 3 minus 1 here. Now I multiply that by the differential of the inner function. If I differentiate x squared minus 3, I should get 2x. That's your answer. Is this clear how I solved? Good. Yes, the answer is correct. Krishna. Everyone clear with how I solved that? So you have to differentiate the outer function, leaving the inside function as it is, and then you take the inner function and you differentiate it. Good. So we will make that, that's how they have shown what we have done. And that's another method that you can use in order to find the chain rule. Whichever formula that you find easy, you can go for that. In here, you are substituting one function as u and other function as y. So this u is your inner function, which is gx, and y is the overall function. Right? So you add u. So then you will do dy over dx, that is equals to dy over du multiplied by du over dx. Then you differentiate separately and you substitute. So that's it for today. I hope that you enjoyed the session. You learned different techniques of differentiation. So we have covered the constant rule, and we have covered Power's rule, product rule, quotient rule, and then chain rule. I hope these rules are clear. Please give me your student ID. I'm sorry for that. Now can you get me? there is one questionnaire on inventorying Moodle shell. I would highly recommend you if you could go and fill in those questionnaire for us. That will help us prove our service, and I hope that you have been enjoying this service so far. Okay, that's it for today. Enjoy the rest of the week and happy studying.